Hi everybody, this is Mrs. Ellsworth, and this is a continuation from that titration lab that I discussed with you, demonstrated for you, I should say, earlier. Anyway, so remember this had that tall glass tube. It's very, very precise measurements. It's called a burette, B-U-R-E-T, and it held a base of NaOH, which had a 0.1 molarity. That was the concentration of it. Okay. And my initial reading was 1.79 milliliters. I wrote that down as I was doing it. And then we went and drained it out so far to 26.69 milliliters. Okay, and what was I pouring it into? I was pouring it into an unknown concentration of hydrochloric acid. I had originally 25 milliliters in here. Okay, and also I put in 2 drops of phenolphthalein. Those 2 drops do not matter at all for the concentration. Anyway, so what we do is that we go and we use this formula. Except for when we used it before, this is when we're diluting things. Now what we need to do is we need to go and change these ideas here. Okay, and we're going to say that this is going to be the molarity of the acid, okay, times the volume of the acid, equaling the molarity of the base, which is NaOH. I'm having troubles here, times the volume of the NaOH. Okay, so you need to write down this formula. You could have also wrote A for acid and B for base too. So what happens is that we're going to be looking specifically for the molarity of our acid. Okay, so we're going to solve this right here for that. I'm going to go ahead and write that down while I'm on this subject right now. Anyway, so what we're going to do is we're going to take the molarity of the base. I'm going to go and abbreviate it like I had mentioned. Okay, so the molarity of the base, I'm going to write a B there for the NaOH, times the volume, that was a V, volume of the base. Okay, and we're going to divide that all by the volume of the hydrochloric acid, which is volume of the acid. Okay, and that is going to equal the molarity of the unknown acid that we were looking for. Okay, and so I will show us how we will use this formula once we get our things inserted in here. Okay, so let's go ahead and talk about this again. My initial burette reading was 0.1. Oops, I need a pointer. Was 0.1 molar of NaOH. Okay, and it will always be that way. So the molarity of the NaOH was always 0.1, and you'll need to do that because you're going to do 2 calculations on your own too, and put that into a Google form later. Okay, so there'll always be that. Okay, we will try our hardest also always to measure out 25 milliliters of the unknown hydrochloric acid. Now, it could have been 24.9 if you were off a smidge, or 25.1. Anyway, so you do your best with that, and we're going to assume in the lab that I'm going to give you, you're going to have at 25.0. That was right on the line. Okay, this right here is going to be a sample. We would call this one sample A, I suppose. Okay, and so what is our final burette reading? Well, I always stack these on different in my data table so that you can do subtraction, because the initial burette reading is always at the top. It's near the 0, so it's a smaller number. Okay, initial means beginning, and then we'll subtract it from the final burette reading. Remember, we read down here, so it's almost up at 0. This is 1.79, and it went all the way down to 26.69. Okay, so here we go, and that makes it a little bit easier for subtracting. Okay, so when I subtract that, I get, let's see, that'll be 10, so it'd be 24.90. Excuse me. Okay, 24.90. And why do I keep that 0 on there? Because of showing my accuracy. That's a 9 there. Woofty, that's ugly. 90. I'm now sneaking over to the next one. Okay, so we went and subtracted. So now that is the volume of the base. The volume of the base right here. Okay, so that is the volume of the base. We're going to take it and multiply it times the molarity of the base. Okay, and then we're going to divide by the volume of the acid. So it's just all those answers are right here. Let me try and rewrite that here. Okay, so I'm going to go down here. Okay, so this is going to equal, oh dear. This is going to equal, okay, the molarity of the base is 0.1. Okay, and we're going to multiply that by the volume of the base, which is 24.90. Okay, and then we're going to divide that by the volume of the acid, right here it is, and that is going to be 25. Okay, look, these two are really close, so the answer is going to be really close to the same molarity as the other one. And when I calculated that out, I did get 0.0996 molarity. Okay, so that would fit in right here. I've got that typed up, so I'll go ahead and put that in there. Okay, and I do have kind of like a little thing, a kind of a crib sheet here on how you go and you figure out all these calculations in this area. It's number 4 up here times number 5. There you go. And then it's all divided by number 6, the 25 milliliters. And so you could also look at that right there too. So I've got a couple of them that I would like you to do. Let me first highlight this here so that you can see that. Okay. And so I'd like you to practice 2 of them. And, oh dear. Okay, so the first initial burette reading that we would say that we had for 2 different samples here. Okay, so we start out, okay, here's letter B, sample B. I'm going to move that over. Sample B, okay, and sample B, our initial burette reading was 0.03. Okay, so 0.03. Try and write with this other pen thing here. It's so hard. Okay, and then you read the burette and it's going to be at 13.47. So I'd like you to figure out the volume and then calculate and figure out what the molarity of the unknown hydrochloric acid is. Okay, then look at this. We're going to do it again. Sample letter C. Okay, let me get a different color here so we don't make mistakes with it. Okay, so letter C. Okay, we're starting again at that 13.47. Okay, because we're just putting another sample underneath it and kept on going. And then this one is going to end at 29.27. Okay, and so what I'd like you to do is I'd like you to calculate the volume so that you can calculate the molarities of the 2 unknown hydrochloric acids here. And we'll check your work with that. And I'll have you enter those 2 into a Google form that I'll make up here real quick, and I will see you later. That's all I got for you right now.